In this video we're going to look at the rules of exponents. For example, something to the power of something. For example, a to the power of b, let's say. Oh golly, there we go. A to the power of b. So this would be an example of an exponent. So the first rule I'm going to work with is a times b, a to the power of b. I'm going to use that little dot there. No, I won't actually. I'm going to times a to the power of c. How would you evaluate that? Well, here the rule is to add the powers. That is to say, add b and c. So we have a to the power of b plus c. Just let's have a look at an example of this. So, for example, 2 to the power of 3 times 2 to the power of 2, that will be 2 to the power of 3 plus 2, which would be 2 to the power of 5. Now you work that out in your calculator, you'll find the answer to that is 32. Not particularly important right now. For example, 2 by 3 times 2 to the power of 1/2. Okay, that's the square root of 2, in other words. Same again, that's actually 2 to the power of 3 over 2. One more I'm going to do. No, actually, I'll sort of save it for later on. No, actually, I'll do it now. Actually, I'll do it in the negative power. Suppose we have 3, let's say, to the power of 4 times 3 to the power of minus 2. There, what we do is 3, 4. 4 plus minus 2 is 4 minus 2, so that would be 3 to the power of 2. That would be 9. So anyway, that's that's an example of the first rule. Okay, that's rule 1. So the second rule we're going to look at is anything to the power of 0. This is a quick one. This is what we call rule 2. X to the power of 0 is 1, as long as, just a little caveat there, as long as x is not 0 itself. 0 to the power of 0 is not defined. So anything to the power of 0 is 1. For example, if we had 2 to the power of x, at x equals 0, then 2 to the power of 0 is equal to 1. Okay. No matter what, anything to the power of 0 is 1. Alright. Let's actually, just to sort of remark upon that. So, 2 to the power of 3, let's say, times 2 to the power of 0. Well, you add 3 and 0, you just get 3. 2 to the power of 3. So that's equivalent to 2 to the power of 3 times 1. Okay, just to sort of, that's not really that important, that statement. I'm just sort of trying to match it to the first rule, rule 1. So anyway, let's look at the third rule now, rule 3. And what we're going to say here is a to the power of b divided by a to the power of c. Now, just as a remark, actually, a here has to be the same as this here. These values have to be the same. The rules don't work if they're not the same. Anyway, how do we evaluate that? That's equal to a, b minus c. So, for example, if we had just 5 cubed divided by 5 squared, that is equal to 5 times 3 minus 2, that's equal to 5. 5 to the power of 1, that's equal to 5. Okay. You can have that with negative numbers now. Watch out for negative numbers. You could have 5, let's say to the power of 4, divided by 5 to the power of minus 1/2. Okay. Here what you do is 5 to the power of 4, 5 to the power of 4 minus a half. Okay, so the minus and minuses cancel out. You get 5 to the power of 4 and 1 half. Or another way you might write that is 5 to the power of 9 over 2. Okay, that might just make it a little bit easier to work with. So that's the third rule. I'm going to sort of come back to something now. I'm going to look at the fourth rule here. So this is rule 4. X to the power of minus n. Okay, so this is a negative number. Can be written as 1 over x to the power of n. Okay. So for example, x to the power of 2 can be written as 1 over x squared. Okay. That's quite useful. Now that actually sort of ties in with the negative powers from earlier on. And that, for example, x to the power of 3 times, let's say, 5 to the power of 3 times 5 to the power of minus 2. If you add the powers together, you would get 5 to the power of 1. Now, that's equivalent to 5 to the power of 3 over 5 squared. Just watch that minus become, if you sort of divide, if you put it under the line or express it as 1 divided by something, then it becomes a positive number. The rule we just seen there previously would work the same way. 5 to the power of 3 minus 2, and that's 5 to the power of 1. So that matches in quite well with the other rules that I've just mentioned there previously. But that's the key thing there. Let it come back up. X to the power of minus n is equal to 1 over x to the power of n. Just watch that you change the signs if you're dividing it by 1 into it, or if you're dividing 1 divided by that number there. Right, this next one is important. So this is rule 5. Okay, so a to the power of b, all to the power of c. In this instance, what you do is actually just multiply b and c together. So you just remove the bracket essentially. For example, let's say 4 to the power of 3 to the power squared. We write that as 4 to the power of 3 times 2. And that's equal to 4 to the power of 6. And then you evaluate it like that. Yeah, I can't really say more about that. This is a very straightforward one. Rule 6. I was doing that in red pen. I'll stay in red pen. Rule 6 is x. Sorry, let's say call it a and b to the power of c. Okay, so a times b to the power of c. That can be written as a to the power of c times b to the power of c. Let's have a sort of quick example. Or actually, 5 times 2 cubed can be written as 5 cubed times 2 cubed. Okay. If you work that out in your calculator separately, you find that that is 10 cubed, which is 1,000. If you work these parts out, you'll find that 5 cubed is 125 and 2 cubed is 8, and that also works out to 1,000. So that works out. But anyway, this is the key part here. A times b all to the power of c equals a to the power of c times b to the power of c. Okay. That's supposed to be a bracket there. Let's just sort of make that a bit nicer looking. Finally, one last one. Rule 7. This is very similar to the last one. X divided by y or I was using A and B, so I'll stick with that. A divided by B to the power of C is equal to A to the power of C divided by B to the power of C. So, for example, 6 divided by 2 all to the power of, let's say, 3. That is equal to 6 to the power of 3 divided by 2 to the power of 3. Okay. You can work it out in your calculator. You get some very similar sort of answer. 216, is that right? 216 divided by 8, you get 27. I'm doing this off the top of my head. You can check that with your calculator. But anyway, that is the last of our exponent rules. They're quite important. They're not too hard, but you do need to know them off by heart. And if you're unfamiliar with them, practice with them. Look out for them, because they do come up, and in a lot of courses you're expected to know them off by heart. And so with that in mind, I'll leave it there. Okay.